Hi everyone, I'm Dr. Ganesh. In this video, I'm going to give an introduction to mechanism design and auctions as a classic example of mechanisms. So, markets, we know markets. There are different types of markets, stock markets, and the internet. We know all this. So, there is a revolution in the definition of market. So the new markets are defined by all these IT giants, the e-commerce companies, and there's the massive computational power available in those giants for running these markets in a centralized or distributed manner. The challenge is to find good models and algorithms for these markets. And over the last 4 or 5 decades, a lot of powerful tools and techniques are developed. A recent study of markets has contributed handsomely to this theory too. Let's take an example of a market called the AdWords market. The search giants like Google made this AdWords market. I'm sure you know what is an AdWord market. When you go and search for something in Google, it may say that okay, this is a sponsored ad, but mostly very relevant to the topic that we are searching for, so it is good for us. And similarly, when you go to Facebook or any other social media, you might see some ads coming in between. So this is essentially the AdWords market. So here are some examples. This is old Google UI. You might get some reminiscing memories. Nowadays, they are much more sophisticated and better integrated. Similarly, an old Facebook page which shows ads on the side of the page. So let's take assume there are n advertisers who has budgets, daily budgets B1, B2, etc. Bn. Each advertiser provides bids for keywords they are interested in. When the queries are coming online based on the keyword, the ad provider should select an ad and advertiser will pay for his or her bid. The goal is to maximize the total revenue for the ad provider. Consider a small example. There are two bidders, bidder 1 and bidder 2. And the query keywords are book and CD. Bidder 1 sells both of them, so bidder 1 is ready to pay $1 for each ad shown on a book or a CD. Bidder 2 sells only books, so he give a quote of 99 cents for each advertisement shown for book and $0 for CD. Their daily budget is 100. Assume there are 100 queries for books followed by 100 queries for CDs. What will be a greedy approach? The greedy approach will actually see that okay, first ad is for a book. Who gives better pay for book? Bidder 1. Let me show his ad and get money. This repeats for all remaining 99. So essentially all 100 bids for books will be shown from bidder 1. Now the CD ad comes, but unfortunately bidder 1's daily budget is over. Bidder 2 does not pay for CD, so no ads shown. It's a lost opportunity and the total revenue is $100. Now let's take an optimal allocation. What do you think is an optimal allocation? If you know the rule of the queries such as 100 books and then 100 CDs all upfront, what could be a better strategy? It's quite clear. When the book ad comes, you show the ad for bidder 2 and not bidder 1. When the CD ad comes, show it for bidder 2, bidder 1, and get a revenue of 199, almost double. But the key challenge here is to know the sequence. How do we know? It is quite it's not predictable, right? So that is a different problem we can tackle using historical data, statistical analysis, machine learning, everything. But given you know such a anticipated pattern, how do you go forward? So with that example, let me introduce auction. So what is an auction? You know, a public sale in which property of merchandise are sold to the highest bidder. There are a lot of examples of auctions including IPOs, radio spectrum, say auctioning a wine bottle, auctioning arts, flowers, a lot of things. There are different types of auctions: sealed versus open. Sealed means nobody knows your quote other than the potential, the seller. So you put it in you put your auction in a cover and then seal it and give. The seller will open check and find out who is quoting better. Open auction, they are even more common. You shout, the seller will say a starting price of $100, and the buyers will start auctioning for bigger amount, 110, 120, 150, 200. Then whenever it stops and doesn't go beyond that moment, they will seal, they will fix it. Similarly, there is also a type of auction called first price and second price. We will see what is it soon. And there could also be uncertainty in sources, so private or common value. We will see each of them. So what is a private value auction? These are some typical Indian food. So if you are a pure vegetarian, you may prefer the one on the banana leaf, the plantain leaf served, because they are all veggies. Versus if you are a non-veg, carving for non-veg, you might like this chicken tandoori. So the private value auction essentially means different people have different values for similar meals. Common value is things like unproven oil fields or the spectrum allocation. So the basic auctions types: open auction and sealed bid auctions. Open auction means English, Dutch and Japanese. Sealed bid auctions are first price and second price. So let's take one by one. English auctions, bidders call out prices. It's called outcry. Auctioneer calls out prices, silent. Or bidders hold down a button, which is Japanese. So there are three types of English auction. In either way, it's only a mechanism how you are auctioning. All are same. Highest bidder gets the object, pays a bit over the next highest bid. So it is essentially ticking down the price. So they start with the highest price. Wherever somebody is ready to pay at a lower price, at that lower price they will fix the deal. Sealed bid first price auction, everyone gives their quote in a sealed cover. Whoever says more will win and pay that much. There is also something called a sealed bid second price auction. The buyer submitting the highest bid wins and pays the second highest bid. So in this example, the one who offered $700 will win, but he will pay only 500. So I'm sure you might be thinking, why such type of an auction? So it is proved that in second price auction, bidders always bid for their true evaluation, which is a dominant strategy. This much amount, say $10, I but quoted say $15, but there is somebody who quoted say 18 and he is winning. So no difference for me from telling my true value and a higher value. Second case, I am quoting at $10, I quoted but 15 and nobody was in between. So why should have quoted that? Even at 10 I should have got it. So my true value is still better. I quoted at my value is $10. I quoted at 15 and I happen to win, but I'm losing money because it is really worth for me only $10. I end up paying more. So it is losing money. So in either of this case, bidding higher than my valuation does not make much sense for me. Now take the case of bidding lower than my valuation. I valued at say 15, but I quoted only 10, thinking I can make some additional profit. But there were people who valued the same item at a higher price and they won. So no difference between 15 or 10. Now I valued at 15, I quoted only 12. Luckily I got it. So there is a small gain in money, but there is much difference between my valuation and what I quoted. And losing money, I valued at 15, I quoted at 12, but someone quoted at 13 and they got it. So even though it was worth for me up to 15, I tried bidding lower and I lost that opportunity. So intuitively, as a small example, this shows second price auction has a good chance. So in the second price auction, always bid your true valuation. I refer you to go and search for the formal proof, in case you are not satisfied with my intuitive example. So more bidders leads to higher prices. Let's take an example. Each bidder has a valuation of either $20 or $40, each with equal probability. What is the expected revenue? Here, when there were only two people following second price, expected outcome was 25. When three people, expected outcome become 30. So let me draw a curve, and it shows after around 15-20 people or 30-50 people, the expected price almost touches the highest value, the true value. So when there are more number of bidders, the second price and first price does not make much difference for the seller. But the advantage is the seller gets true value of the item as perceived by buyers, because there are no incentive for the buyers to quote a different number. There are also online auctions, including increase auction, decrease auction, sealed bid, sealed price, second price sealed bid auction. By the way, the second price auction is also known as Vickrey auction, named after the scientist mathematician 48-50. There are also combinatorial auctions. The seller would like to sell multiple interrelated goods. If we sell only goods in separate auction, agents have a hard bidding problem. So some of them may want to sell two items together only. But determining the winner in combinatorial auction is proved to be NP hard. So this summarizes different types of auctions that we discussed. The English and the Dutch, which are single auction outcry, versus second price or Vickrey and first price are sealed bid single auction. Double auction is in the presence of a mediator. Call market is an outcry method in double auction, and continuous double auction CDA is a sealed bid approach in double auction. Some references for learning more, seeing some additional examples on these auctions. Now auctions, by giving an example of auction, what I have introduced to you is nothing but an algorithmic mechanism designs overview. So what is a mechanism design? See these examples. A mechanism can potentially turn this into some of this. So a mechanism is nothing but finding the correct rules and incentives for making things better for a social welfare. Auctions are actually a mechanism, right? That's a way of selling something, disposing something, buying something. So it can be viewed as a reverse engineering of games or equivalently as the art of designing the rules of a game to achieve a specific outcome. So the main focus is to create protocols that satisfy desired objectives. Large networks like internet are built and controlled by diverse and competitive entities. The entities have different preferences, they own different components, they hold private information. For such a diverse environment, mechanism design is a useful tool to design protocols. So every single internet protocol that you have used or heard in computer networks is also an example of a mechanism design, for example. And classic example is auction. I don't want to spend a lot of time on auction. There are different players who value different items. They tell my value. If a simple mechanism is no money needed for the art, but you tell your price, everybody will say I am ready to pay infinity, isn't it? So this mechanism does not work well. Then pay your bid. But each player may lower their money. So the seller may not get the right price. And we already said Vickery's second price auction is the better strategy so far. So that is another possibility. That is another mechanism. So we can use that for various jobs. For example, jobs to be allotted to machines and cost incurred if each machine does the job. So this could be maybe second price auction or something can be used. So instead of maximizing, I will go for a minimizing version. Or it could be multi-unit auctions. I want to sell k units of this item. Or a public project to build or not to build a particular bridge, considering the cost and how much people value that particular bridge. Are they going to use it? Or a bilateral trade where the item needs to be sold only if the value for the buyer is greater than the value for the seller. Or it could also be buying a path in a network. There are costs associated with each path, each edge, and then I want to find out a shortest path. So an environment, to summarize formally, there are n agents, and agents are rational and intelligent, and set of outcomes or alternatives. Then there are also a private value associated with each agent known as the type. And individual agents have preferences over outcomes and a set of outcomes which are common knowledge among all players. So to put together, illustrate in a picture, this is taken from Y. Narahari's Game Theory and Mechanism Design book. It's a good book. I would recommend if you are exploring to learn game theory, please go refer to the book. It's a good source of information. So there are individual type sets, individual types, reported types, which could be different from my original type. Then the social choice function which we want to achieve. Then the decision of getting the outcome, and based on the outcome, utility functions are applied to get utility values. So I would say you can go and explore VCG mechanisms, Vickery, Clark and Grove mechanisms. And with that, I thank you for your time to listen to this video. Bye.